Okay, so adjusted intervals, really all that is it's really kind of more of a method for how to solve these whenever your angle isn't kind of straightforward. So you can see the angle is getting divided by two. So typically you would think that where cosine equals zero would be at values like zero and pi or whatever. But the problem is if you plug in pi, you would get cosine of pi over 2, which that does not equal 0. And so what we do here, adjusted intervals, what you do is you adjust where you're going to be looking for these angles and try to make it a little bit easier to work with. So what we do here is whatever's occurring to the angle here, go ahead and apply that to your interval. So you're going to divide both of those by 2. And so that, I mean, that's the answer. That's the adjusted interval. But why? Why is that important? Well, then what you do is you take this equation and you look at it as though it were just cosine of x. And so cosine of x equals 0, that would be at 0 and pi. But I already showed you that pi doesn't work, right? If you plug in pi, it would not work in the original equation. But what you do is then you basically undo what you applied to the interval. So you divided those values by 2. So then what you're going to do is you're going to multiply your answers by 2. And so 2 times 0. So 0 still works. And then your other angle would be 2 pi. And so those are the two values, and they're within this interval right here. And if you were to plug them in for x right here, it would work. Um, all right, so let's look at one more like this. So by the way, I mean this is the answer. That's the adjusted interval, but I just wanted to take it a step further because the whole purpose of it is kind of make the solving part easier. So on this particular one, they're multiplying the angle by 4, so that's what we're going to do. We're actually going to multiply both of these by 4. So my adjusted interval would be from 0 to 8 pi. And so that's the answer to this question. But if you actually wanted to go a step further and solve it, so then what you do is you kind of, for a moment, just think of this as being sine of x equals 1. And so you want to figure out all the places where sine of x equals 1. But you want to look at it over this interval, and you'll see why in a second. So let's see. So sine equals 1 at pi over 2, and then also at 3 pi over 2. And then if I were to continue, my interval is bigger than what I had up here, so I can do multiple rotations. And so then the next one, you just basically keep adding a pi because you're just going to keep doing a half rotation around. And so you just keep doing this. Let's see, 9 pi over 2. There's going to be a lot of them. Let's see, 11 pi over 2. Let's see, 13 pi over 2. 15 pi over 2. And then I believe that's going to be it, because if I go up any higher, I would go beyond 8 pi. So what I'm doing here is on my unit circle, here's where pi over 2 is. Here's where 3 pi over 2 is. And then if I keep going around the circle, that's where 5 pi over 2 is, and so on and so on. I'm not going to write them all down. They're all right here. Now, those are not my answers, though. Those are the answers for this right here. And so I have to go ahead and convert it back to my original equation because my angle is actually getting multiplied by 4. So I'm going to undo that by dividing all those by 4. So I'm going to divide all these by 4. Or that's the same thing as multiplying by 1/4. And so if I multiply these all by 1/4, this would become pi over 8. This would become 3 pi over, basically, I guess all the denominators are going to turn into 8, it looks like, because there's nothing that simplifies. You have to be careful because sometimes when you do this, there might be some simplifying that would take place, but it doesn't look like anything will happen here. But anyways, I'm not going to write them all down. But all those angles actually satisfy this one up here. And if you look at this, all these angles actually will be between 0 and 2 pi. So the short of it is basically adjusted intervals is just a method for kind of making the process a little bit easier. So you're kind of simplifying it into sine of x, find those answers with that adjusted interval, and then you have to adjust those solutions to fit your original interval with the original equation. And if you don't believe me, you can plug these in and you'll see that they work. All these in red that I wrote down, if you plug them in right here, sine of 4 times x, plug any of those in, you are going to get a 1 there. So anyways, I hope I didn't overcomplicate it. I just wanted to kind of give you, show you how to find it, but then also give you the reasoning behind it. So if you need anything else, just let me know.